Good morning. Next, here the subject name is Principles of Programming Language. Here in this programming Principles of Programming Language, we are having this is the syllabus software development process. Next one, language and software development environments. Next one, language and software design, language and computer architecture, programming language qualities, a brief historical perspective. Next one, language definition, language processing, variables, routines, aliasing and overloading, runtime structure. This is the Unit 1 syllabus. Here first, what is meant by programming language? First, what is meant by the programming language? Here, a programming language, it is a computer language. It is designed to communicate instruction to a computer. Here, what is in a programming language? It is a computer language and it is designed to communicate computer. We are giving some instructions to the computer. That is called the here programming language. Here a programming language, it can be used to create programs to control the behavior of a computer. Here in this programming language, it can be used to create programs to control the behavior of a computer. It is called the here programming language. We have to use to create programs. What for we are using the programs means to control the behavior of the computer. Next, that is called the here programming language. Here in this programming language, we are having first topic is software development process. Software development process here. Here what is meant by the software here? Here it is electronically stored data. It gives instructions to a computer. We are giving some instructions to that computer and it is stored data. That is called the here software. In this software, we are having divided into some of the phases. In these phases results in the development of either a system or associated with that system. It is called the here software here. In this software development process, it is based on some of the models here. In this, it is based on the waterfall model. Here it is divided into some of the phases. What are the phases here means? First one, requirement analysis and specification. Next one, software design and specification. Next one, implementation in that coding. Next one, verification and validation. Next one, maintenance. These are the following phases come under the software development process. Here, first one, requirement analysis and specification means software design and specification. Here, starting with the requirement, starting with the requirements document, we are having the software designers to design the software system. Here, the result of this phase, it is a system design specification. It identifies all the modules to the system and their interfaces. Here, in this software design, and you have to specify that software design, you have to starting with the requirements document. Starting with the requirements document for the software designers to design the software system. Software designers design the software system. You have to start with the requirements document. Here, in this to result of this phase, here it is a design specification and to identify all the modules, and their interfaces. Here in this software design, here what the problem is and how to solve the problem. Here what the problem is and how to solve the problem. Here, the purpose of this design phase to specify a particular architecture, particular software architecture. Here, in this software design phase, its understandability and modifiability. Here, the choice of this programming language also to be used in the system implementation. That's why here as a software design in this requirements. Next phase is the implementation. Next phase is the implementation, means coding. Implementation means coding. Here the system, it is implemented to meet the design specified in the previous phase. Implemented here, previous phase means system. Here previous phase means this is the requirement, software design and specification, means we are having some of the requirements. That is the previous phase. Here next it states that this implementation, what the goal of the implementation step. It states this phase, the goal of the implementation step is to choose how among the many possible ways the system shall be coded to meet the design specification. The system shall be coded to meet the design specification. Here the result of this implementation and documented system. The result is fully implemented and documented system. Here this is called the here implementation or coding. Here in this next phase is verification and validation. Here this phase access the quality of the implementation system. This phase access the quality of the implementation system. It is then delivered to the user. This phase, it quality of the implementation system, which is then delivered to the user. Here next one, verification. Verification means, are we building the product right? That is called the verification. Here validation, are we building the right product? That is called the here validation. Next maintenance. Next one is maintenance. Here in this maintenance, in this phase, we have to deliver the changes to a system. Become necessary, either become detected malfunctions, means is there any changes to that system. It is changes in this maintenance only, means you have to add the new capabilities, or you have to add the new features, and you have to add the how to improve old ones, and you have to change the operation environment. That's all come under in the maintenance phase. Means example here, the operating system of the target mission. These changes are referred to as maintenance. Here while delivering changes to the system may become of detected any changes for that project. In this means you have to add the new features, you have to add the new capabilities, you have to changes in the environment, you have to change the environment in that, and these changes are referred to as maintenance. Next, that is the software development process. Next topic is the languages and software development. Environments. Here in this phases, here the work in any of the phases of software development may be supported by some tools. The tools are called the computer aided tools. Here These computer aided program development tools have to increase by using these tools, have to increase the programming productivity, have to increase the programming productivity, have to reduce the chances of errors, have to reduce the chances of errors here. This environment, it is used in some of the phases of the software development. What are the phases means here? Requirement, design, implementation, verification and validation, maintenance. These environment is used in these phases of the software development. Here in this, we have to work any phases of the software development. It is supported by the computer aided tools. Means why we are using these computer aided tools means here these tools are used. These are tools used to have increased programming productivity and reducing the some of the errors, chances of the errors. That's why we are using these computer aided tools here. These are the 5 phases of the software development. Next, first one is the requirements. Here, in this requirements, a team of application and computer specialists have to interacting with the environment develops the system requirements. Here, a team of this application and computer specialists have to interact with the environment develops the system requirements. Here, in this requirements have developed and updated, and you have to incompleteness and inconsistency. Means you have to these are the developed and updated, incompleteness and inconsistency of their requirements here. Here in these requirements, it also provides facilities to validate requirements against the customer's expectations. It also provides facilities to validate requirements against the customer's expectations. Here these are the requirements. Next one, designing. Designing means in this designing we are having system designers have to interact with the environment. You develop an initial system design and they specify the needed modules and the module interfaces. Here in this designing we are having system designers. Next have to interact with the environment and they have to develop the initial system design and have to specify the needed modules and the module interfaces. These are the design part. Next, implementation. Here this implementation can take to the implement the system based. You have to implement the system based on the design. System based on the design. Here this environment provides the support for these phases by automating some development steps. By suggesting this reuse of the existing design. Means we have to we have some design that is meaning here existing design. You have to implement components to that taken from the library. Library means already we predefined components. Already we predefined components. You have to take that components. You have to provide these phases and you have to develop the design. Here next point is the tools provided by the software development environment to support implementation are the most familiar here. Here these tools provided by the software development environment to support the implementation of the most familiar here. Here this in implementation you have to including the programming language processors. What are the language processors means? Here you have editors, compilers, simulators, interpreters, linkers and debuggers and others. Here you have to include the programming language processors such as editors, compilers, simulators, interpreters, linkers, debuggers. These are the programming language processed by the implementation here. Next, implementation means coding. Next is the languages and software design methods. Here languages and software design methods are models. Here in this languages to understand the relationship between the programming language and design method. Here you have to understand the relationship between the programming language and design method. It is important to realize that programming languages a certain programming style here, that is called the here programming paradigm. Here programming paradigm. Here how to understand the relationship between programming language and a design method. Here it is important to realize the programming languages may a certain here programming style. This is called the here programming paradigm. What is called the program paradigm. Here some of the software design models here. Some of the software design models here. What are the software design models here means? First one, procedural programming. First one, procedural programming. Here this is procedural programming. It is a conventional programming style here where programs are decomposed into some calculation steps that perform the complex operations. Perform the complex operations here. Here in this procedures and functions, these are used as the modularization units. Modularization units to define such computation steps. To define such computation steps here. Example here C and Pascal language. C language and Pascal language. Some of the languages have to define the routines. This called the routines. Means some programming languages it called the functions. In C programming language we are using some functions. Some in Pascal programming language we are using the procedures. In some programming languages procedures and functions that are called the routines. These are used as the modulation units to define such computation steps here. It is the conventional programming style where programs are decomposed. Means you have to divide that calculation steps that perform the complex operations here. Next first model is procedural programming. Second model is functional programming. In this functional programming, it is style of programming. It is rooted in the theory of mathematical functions. Theory of mathematical functions here. Here, the use of these expressions and functions here in this functional programming, it emphasizes the use of the expressions and functions here. The functions are these are the primary building blocks of the program. These functions are the primary building blocks of the program. Here, these functional programming is passed as parameters and it is constructed written as the result parameters. Result parameters of that functions. That is called as Fortran, means formula translation. Fortran means formula translation programming language. Is one of the functional programming language. One of the functional programming language. Here in this function style progressed in the theory of mathematical functions here. In Fortran programming language, the functional style of programming is theory of mathematical functions here. The use of expressions and functions here. These are the primary building blocks of the program here. Here these are the past parameters. It may be constructed and written as result parameters of other functions here. Example Fortran. Example Fortran. Formula translation programming language. Next one is the abstract data type programming. Next one is the abstract data type programming. Here in this ADT means abstract data type programming, it recognizes the abstract data types as the unit of program modularity. Means abstract data type programming, it recognizes the abstract data types as the unit of program modularity. Unit of program modularity. Example Haskell programming language. Example Haskell programming language. Next programming language is module based programming language. Module based programming language. Here in this module based programming language, it emphasizes the modularization units. Modularization means modules means already we predefined functions and we have to reuse that code. That is called here modulation units, that are grouping of entities such as variables, procedures, functions, types, etc. Here, these are the entities. These are the group of entities called the variables, procedures, functions, types, etc. Here, a program, it is composed of a set of such modules here. Here, a program is a composed of set of such modules here. Here, next, these modules can be used to define precisely, means clear, means to reported to the outside world by the module. Outside world by the module here. Here, in this principle, any kind of service can be provided by a module, not just the ability to generate and use abstract data. Use abstract data. Here, for example, what are the module-based programming languages means Modular 2 and ADA. Modular 2 and ADA. These are the two types of programming language. It is based on the module based. Abstract data programming language is Haskell. Abstract data programming language is Haskell. Next. Next one is object-oriented programming language. Next one is the object-oriented programming language. Here, these object-oriented programming style, it defines the classes of objects. Classes of objects. Here, instance of the class are created by a program during program execution. How to instance of class to created by a program as needed during program execution here. Here it is based on the definition of hierarchy of classes and runtime and selection of units to execute here. Here the definition of hierarchies of classes and runtime, how to selection of units to execute here. For example, we are having Smalltalk, C++, ADA 95, Java. So example, Smalltalk, C++, and ADA 95, Java. These are the object-oriented programming languages. Next, generic programming. Next one is generic programming. This generic programming, this style, the definition of generic modules that may be instantiated either at the compile time or runtime to create the entities. Either at compile time or runtime to create the entities, data structures, functions, and procedures. It is needed to form the program here. In this generic program, we are having the generic modules that may be instantiated either at the compile time or runtime to create the entities like data structures, functions, and procedures needed to form the program here. Here, this approach, it is to programming encourages the development of high-level generic abstractions as units of modularity. Here, in this generic programming, it does not exist an isolation here. It can exist. It exists jointly by the object-oriented programming here. In this generic programming, what are the generic programming language? ADA and C++. ADA and C++. These are the to create the entities like data structures, functions, and procedures in C++, and we are used in the so these are the generic programming. These are the generic programming. Next, declarative programming language. Next one is the declarative programming language. Here, in this declarative programming language, it is a description of a problem and a decomposition of the problem into an algorithmic implementation. Such programs are close to the specification here. Means what are the programming languages or declarative programming languages means programming in logic. Prolog languages, programming in logic, and rule-based languages and rule-based languages. These are the emphasize the declarative description of a problem to the decomposition of the problem into an algorithmic implementation. These programs are close to a specification. Close to a specification. Next. These are the languages and computer architecture. This is the one human architecture. Input, output, memory, and CPU. In CPU, fetch instructions, execute, and how to store the result. We give the input to that memory In that memory, you have to go to the CPU, means you have to fetch that instructions and you have to execute and you have to store the result. You have to store the result. It's called the one human architecture. One human architecture. Here in this, the one human, it is based on the idea of memory. The one human architecture, it is based on the idea of memory. It contains data and instructions, a CPU and input output unit. Means it is based on the idea of memory that contains data and instructions, a CPU and input output unit. Here in this CPU, it is responsible for taking instructions. It is responsible for taking instructions out of memory. Take out of memory. Here, one at a time, machine instructions are very low level. Machine instructions are very low level. Here, next point is you have to require the data to be taken out of memory. It is manipulated via arithmetic or logical operations in the CPU. Here, this instructions executed the state of the machine. State of the machine changes here. In this one human architecture, we are